Hello, and thanks so much for joining us here today at the SMPTE Toronto Technical Conference 2021. My name is Paul Briscoe. I'm Chief Architect at Tag Video Systems. Let's have a little walk through an OTT primer. Definitions are always good, so what is over-the-top television, OTT? Well, it's a new method for distribution of TV and movie content, which goes over the top of existing and legacy distribution methods. It provides access to a vast array of content, both free and paid. It's geographically diverse, and it's regionally or even down to your address aware. It offers new advertising opportunities, it offers new content sources, and it brings the ability to deliver to any consumption experience, a phone, a tablet, or a giant TV. And perhaps most importantly, it uses the internet and it uses cloud technology. As things do on the internet, it all started innocently enough. A couple of websites that we know today started doing somewhat different things. Netflix started renting DVDs by mail despite having the name correct. YouTube started with cat videos. Neither one looked like it was the future of television. Well, they're not so innocent anymore. The 2020 revenue for Netflix was $25 billion. It was nearly 20 for YouTube. So those cat videos have turned into something a little bit more than what they originally started out to be. We haven't seen our model of TV broadcasting change a lot in a long time. In the beginning, this was our model, right? We had a TV station, we had a TV set. They transmitted programs, you tuned them in and watched. Television grew, more stations came on the air, you had a channel dial. You could change the channel, you could watch different programming, all of it scheduled, all of it commercial driven, but from different stations. Some were further, you put an antenna on your roof, you could get a few more channels. There were options for choice, and this carried us into the color TV era. Around about then, a new kind of choice came along, the cable TV system. This is where over-the-air stations from all around the region could be brought together, put into a bouquet of channels, and delivered to you through a coax cable through a cable plant. Covered your city, you had a drop coming into your house, set-top box in your TV turned it into something that you could watch. Now you had even more channel content available to you. These systems grew from being a local cable system who just had a bunch of antennas on a hill to increase the channel count to regional and national cable systems, which then use satellites to share signals between them to further increase the choice available in the channel bouquet. Then along comes the direct-to-home era, the cable plant in the sky, where all these cable systems can then be aggregated to provide even more content, and these can be groomed and provided into packages which are delivered over satellite to a DSS receiver and a satellite set-top box in your home, giving you yet again even more choice of channels. And then the final step of this evolution was the addition of content libraries to these distributors, such that now using a back channel, originally through a telephone modem and more recently through the internet, your set-top box could request a movie such that next time it aired, you could watch that movie by subscription for a small amount, provided you subscribe to that service, from their content library. The content library was the beginning of some of the change that led us to OTT. The other thing that led us to OTT was at this point in time, despite all this technology, and we've now evolved to the UHD TV era on this architecture, we still have the same business and social model. It's a scheduled TV broadcasting environment with inline advertising. It's a curated program content list that you have no choice in. Your only choice is channel and when you're available to watch TV or have the patience to program your PVR. Perhaps the biggest thing that drove us to this point is that non-TV set devices, which fill our world today, aren't accommodated by TV broadcasting. Desktop computers, tablets, mobile phones, simply not accommodated. In fact, mobile broadcast has been tried in North America in the past with ATSC mobile and fell flat in its face. Nobody wanted mobile phones with TV sets in them. Instead, they wanted the opposite. They wanted TV to come to their mobile phone. So we find ourselves with a changing media landscape. TV has spanned quite a number of generations of consumers. But the internet has created new consumer social contracts. So for me, who's an older guy, I've always known TV. It's just been part of me, but I'm young enough that the internet grew up as I was, an adult. And so I'm familiar with and I embrace these new social constructs. And these new social constructs are what are driving a lot of what's making OTT rise. One of these is advertising is evil. And this is it's a concept that comes with the internet, not just because of television advertising being evil in general, because everybody hates advertising, yeah, but the fact that on the internet we're just deluged with advertising. So people don't want advertising to be irrelevant. They don't want it to be pervasive. The internet also has commodified video. Video used to be a very special thing, and those walls are broken down. Those silos are now crumbling. YouTube, home video capture and editing just makes video trivial. Everything's interactive today. Television is non-interactive. People today, the younger audiences, want interactivity. And they want choice. They want a choice of what they watch, where they watch it, when they watch it, and what device they watch it on. So this is being driven by a much younger demographic, what I call internet natives, people who grew up with the existence of the internet their entire life, for whom this stuff is just natural. Why the internet? Well, the internet's a communications commodity. It's got bandwidth ever increasing. It's got reach ever increasing. It's got rich services available and capabilities. And it's ubiquitous. It literally is becoming everywhere. It's becoming like running water or electricity. It's agnostic to video and audio. It doesn't actually care about what we do versus what anybody else does. It moves packets around, which is wonderful. All we have to do is harness the power of these packets. There's so many consumer devices available for the internet, media devices and otherwise, Internet of Things devices. And there's more coming. There's no end in sight for internet devices for consumers. It's robust. It's multi-technology based. It's continuously evolving. And very importantly, cloud computing lives there, or the other way around, depending on how you look at it. So it all sounds great, but it's not that simple, right? What we do today counts on determinism. We need to send video pixel by pixel, frame by frame, and it's all got to get there, and we don't have room for jitter, and we don't have room for packet loss and things. That's why we use private protected content highways that get the content guaranteed delivered to the consumer. And we push it because that works. We push it down this pipe and it arrives. The latency is low, that's fine. And we adhere to rigid normative standards. This guarantees interoperability because this is all hardware based. And when you build hardware, you got to build it right if you want part A to fit part B, just like nuts and bolts. And these standards are things like the actual media formats, HDTV, compression formats, transmission formats, packaging formats. There's also standards such as over-the-air regulations that have to be considered. On the internet, how do you manage over-the-air regulations, or do they matter? The internet isn't necessarily inherently good at these things. So from a technical point of view, to use the internet, we need something to ensure delivery determinism. We have to make sure the programming arrives. And we need internet-friendly mechanism. The internet is not good at things being pushed through it. The internet is based on pulling. When you browse the web and you click on something, you're pulling content to your browser. Latency, well, when and why does latency matter? Does it even matter? When you're watching TV, do you actually know how live it is? Do you care? There are rigid standards we have to consider. We have existing video and audio standards. We may as well use them. They're everywhere. At the same time, we need new standards, and we have, on the internet, new evolving standards all the time. Everything's software based on the internet. This is wonderful because software, of course, is software. Nobody wants to buy purpose-built hardware if they can avoid it. And that's why your phone does everything it does, is because it's just a computer and it's all software. Another important thing is cloud residency. If we can't use the internet effectively as more than transport, we don't get all of its benefit. But because of cloud computing, we can do amazing things with the internet and the cloud. And we have these software-based consumption platforms. That's really important because the ability of the platform to follow what's being broadcast is key. Today, we can't transmit something new because the receiving devices don't know about it. And the internet is very, very good with this kind of uncertainty and this kind of evolution. So what are some of these new requirements? Well, screens. We have many new image resolutions because we have little screens and they don't have as many pixels as big screens. We also have big screens that have more pixels than they used to. Aspect ratio is king, mind you. But these new resolutions don't have anything to do with the resolutions we normally are used to. But the aspect ratio, of course, is the same. We have super high resolution. We have HDR. We have other requirements like device handover, where you stop watching on your phone when you get to your TV and continue on the TV. Co-viewing, where multiple people can share a viewing experience while not being co-located. Usual things like pause, rewind, fast forward, park, maybe record. Targeted advertising, super important. I don't want to get advertising, but if I do, I want it to be relevant. It could be regional, that's fine. It could be local, that's good too, if it's useful to me. It could be personal. the better the advertising can be targeted, the better for the commercial end of the business and the better for the consumer. But the most important new requirement is how to handle present and future compression and transport formats. And the answer, of course, is because it's all software, it's software. So all is not lost. We can reuse a lot of stuff we have today. We can use our aspect ratios, our resolutions, our frame rates, our color volumes. These are well established. They're supported by legacy systems and existing systems today. And there are eons of content available that respect these things. So we can reuse these, and it would be senseless to ignore them. We can also use today's video compressions. There will be new ones in the future, but MPEG-2, especially MPEG-4 and HEVC, absolutely. Audio formats and audio compressions we have available, absolutely we can use those, and MPEG-T as transport. In fact, that was used in an early part of OTT as well and remains so today. So quite simply, the way it works is we use TCP/IP for guaranteed delivery. In TCP/IP, we use automatic acknowledgement such that if a packet is lost and not acknowledged, or if the packet is errored and bad on receipt, it's not acknowledged with a NAC signal and it's retransmitted. If possible, TCP/IP will deliver a packet. This takes care of our delivery guarantee problem. We pull the content, so the viewer is not receiving content that's coming out of the end of a hose, they're actually pulling the content. This is very much a web-centric model, and it's based upon transfer of chunks, small pieces of media streams, one after the other. And we're not talking frames, we're talking much bigger chunks. The system provides multiple renditions of the content. This is the adaptive bitrate part of OTT. This is where there's not only a huge screen UHD TV version of that content, there's also a small screen iPhone version of it available. And the player then can pick which one to use when it goes to pull this content. And most importantly, the player can change what it pulls every chunk by chunk. So if the internet conditions, for example, degrade on a mobile player, it can switch to the lower resolution stream to avoid buffering and continue playback, perhaps at a slightly lower resolution. So super simply, it works like this. We take audio, video, and metadata, we'll call it a program, and let's break it into 10-second pieces. And take each 10-second piece and make a file out of it, we'll call a chunk file. Now we render this content to various resolutions. We decide in advance we want to serve phones, we want to serve laptops, we want to serve TV sets, we pick resolutions for that. And we make these different resolutions, we make these chunk files. We can make these resolutions before or after we chunk these files. But this is the adaptive bitrate part. And then we create, for every one of these 10-second chunks of quality, we create a TV guide called a manifest file, which says, okay, here's what the different available file names are, and here's what their qualities are. And it also creates a history of the recent ones that are available and some other metadata, and we post it on a file server. And then we go and we do it again. So what we end up with then is a whole bunch of different variants of the program in 10-second chunks, the most recent handful of them sitting on a server, and a TV guide that tells you what they are. Time to play out. Your player contacts the server, logs in if necessary. You go to the program you want to view, you go to the one we just talked about, and you pull the manifest file and you have a look. And you see what's available. Now, you know you're a big screen TV, so you need the high bandwidth version, and you know your internet quality is good, so you pick the highest rendition, and you pull that chunk, and you start to play it. And you play it. And there's a previous chunk playing, and the last frame of that chunk, the first frame of your new chunk plays. And while it's playing, you go and you look and you wait, and the new manifest comes, and you have a look at the TV guide in the manifest, and you say, oh, yeah, I'm going to pull another chunk, and you do it. Every time around, you look at the circumstances based on network conditions primarily, and you decide whether or not to change which stream you're watching. So you can adapt based on a number of factors. The bandwidth, the network conditions, such as jitter or packet loss. What's the display? What's the audio? What are the capabilities of your viewing device and compute power and so on? What are your user preferences? Maybe you've got certain preferences for what you want to watch. Maybe you want to manage bandwidth and keep the bit rate low and the low quality rendition going. Your provider may have services they offer or limitations they impose. And it doesn't matter because your player can adapt during playout to give you the best quality. Every time the chunk boundary changes, it's going to make the best decision for a quality viewing. Here's a quick visual representation of what's going on. We have 3 streams of the same video, one at 10 megabits, one at 4 megabits, and one at 1 megabit, intended for big screens, medium screens, and small screens. Every 10 seconds we have a new chunk, and the player evaluates conditions. So the large screen TV with solid bandwidth, the green line, plays the 10 megabit stream the whole time. It's 1928 1080 HEVC. Beautiful. The large screen TV with the varying bandwidth, maybe somebody's gaming in the house, it's the blue line. And when the bandwidth decreases, it simply switches down to the next lower rendition. No buffering, no queuing, nothing goes jumpy. Just switches down to a slightly lower resolution. Meanwhile, we have a small device. When bandwidth is good, the gray line is playing 4 megabits. When bandwidth gets poor, it goes down and plays the lower rendition. This is the up and down mechanism of adaptive bitrate. So how does it work on the internet? Well, here's a model of the internet, super simplified. You basically have servers all over the internet. They're connected together. They're available. You get to them through a very small piece of the cloud called your local internet service provider. And that's where you get access to all of the internet services. You consume them on any device you want. TV set, phone, laptop, tablet, whatever. So the OTT consumption model looks like this. It's the same internet. It's the same devices on the right-hand side. We have some content, in this case coming from a media server outside the cloud. It could be in the cloud or a camera outside the cloud. It comes into an encoder or it comes in pre-encoded to a transcoder packager. The transcoder packager is two pieces in one here. It really could be two separate things. But here's where we do the transcoding from whatever highest quality format comes in to the lower resolutions in the adaptive bitrate ladder. The packager as well puts together the chunking. It takes care of chunking these down into their files, so every rendition becomes a series of chunk files. It then packages them with the manifest file and delivers them to an origin web server. This is the point of contact for your viewer. When viewer wants to watch the content, they contact the origin web server and begin to pull the content after they pull the manifest and figure out exactly what is appropriate to pull and start to watch. Now, of course, having millions of viewers pulling content from the same content delivery network web server isn't going to work. So it's actually replicated across the network with multiple point of access servers, and you access the one nearest to you. And then there's one more step which is becoming very useful, and that's edge caching. It's already done for internet browsing for a very long time, but it works really well here because statistically popular traffic, meaning content, can be kept close to the edge based on the logic and algorithms inside the edge server. So it means that the next viewer to come online to watch what you're watching doesn't actually necessarily have to go back to the content delivery network. It can get it from the edge of the network. So what it means then is popular content can be kept near the edge for quick access and to keep bandwidth down inside the infrastructure. You can also push local high-demand content to the edge and leave it there, and it becomes a local origin proxy for that content. And the most interesting part about the edge server is this is where we can enable local ad insertion, because the edge knows about you. Your ISP knows where you live, and the ads know about where you live and who you are, and your browser tells people all about you, and there's lots of data available to deliver ads that are meaningful to you, whether you like it or not. So the final model looks like this. We have an origin web server, and it feeds a whole bunch of edge servers, and these caching servers all around the internet, between them and the network of origin web servers, provide easiest and lowest bandwidth point of access for all consumers. So let's talk about OTT versus traditional broadcasting. Where's it going? Well, in a word, up. OTT has a low uptake by an older demographic. Could be partly because devices are confusing to use and not that popular in that audience. Perhaps it's uncomfortable to have that much choice or confusing. There may be a lack of interest in some of the content or a lot of the content. There may be a lack of trust in new services. I mean, TV broadcasters, especially local TV broadcasters, have long been a trusted part of the community. Meanwhile, it has a very high uptake with younger viewers who are familiar with choice. They're familiar with variable devices. This stuff is second nature. And they're much more savvy around trust and the internet and the complicated equation around trust in the internet. The supporting technologies for this are ubiquitous. They're everywhere and they're growing, and it's unavoidable. Traditional technologies are hardware-based. They're non-evolutionary. This is all software. Traditional programming is following its audience. And OTT is in fact doing the same thing. This chart tells a quick story. On the left are the hours and minutes of viewing for 5 age categories from 12 to 65 plus. You can see that the longer times are at the higher ages. On the right is a percentage change viewing time year over year over the same age bracket. So you can see where the time is being spent watching broadcast television, and the time that's not being spent in the percentage change, you can imagine, is going over to OTT. Another key factor is things like this. Don't want to pick on Apple, but 5 nanometer CPU with 16 billion transistors, 8 GPUs, 8 CPUs, 16 core neural engine, image signal processor, media encode and decode engines. There's no wonder we don't need bespoke hardware solutions anymore. To have this kind of capability in your pocket, in your phone, opens the door to incredible capabilities in the future to build on top of today's OTT technology. So where does this leave us? Who are we? Well, we're media technologists and providers. It leaves us on a rapid learning curve because we have completely new technologies, which is IP, not traditional for us. We have evolving technologies, which is IT, the actual industry behind the use of IP. And we need to establish deep collaboration with IT and data center experts. There's high specialization required in these new areas. And this means new skill sets. Especially not just for us. IT-centric people don't have the TV background and vice versa. So partnership and community is key in all of this. In addition, there's a shifting business landscape we have to be aware of. Software companies are rising, hardware companies are evolving, and there's consolidation in both the content and distribution arenas. But the future is bright for OTT. Existing broadcast audiences are aging out, and meanwhile the internet kids are growing up and their kids are scary comfortable with technology. The existing broadcast industry has to evolve and is evolving into the use of OTT, and that's how they'll win the future. Where will the content come from? It'll come from everywhere, places we don't even know. What'll happen to the internet? Well, it'll just keep growing. Bits are dollars, and as long as bits are dollars. And with the kind of power we can run in CPUs today, with better codecs, smarter distribution architectures, there's no end to what we can do in the future of media consumption and media experiences for viewers. And hard to believe, it all kind of started with DVDs in the mail and cat videos. Thank you for joining me for this today. It's been my pleasure speaking with you. Stay safe.